Unit 2, we did start last semester. The first half was about exponential functions. We started looking at arithmetic sequences at the beginning of Unit 2, looking at patterns where we're adding by a common difference of d. Again, we talked about these two couple of formulas if you talked about arithmetic formulas. So now again, I wouldn't really memorize this formula. This is kind of similar to this, and we're going to talk about this formula today, this y minus y1, x minus x1. So you can kind of think about it like the same formula, but those two formulas are kind of the same. You will need to know this formula for the FRQ number 2. So just kind of know these two formulas are kind of the same. Again, this is almost like y is equal to mx plus b too, if you want to think about this kind of like linear functions instead. So then we talked about geometric functions when we're multiplying by a common ratio, multiplying by r. And we can either write that as g to the power of 0 or times r to the power of n, or g to the power of k to the r to the n minus k, where r is going to be our common ratio, n is going to be the number of terms we have. K could be any term in the sequence. So talked about those two things kind of first. After we talked about sequences, we talked about exponential functions. Again, exponentials, typically the x's are going to look like they're equally spaced apart. The y's are going to look like we're multiplying. So if I do like 3 times 3 is 9, times 3 gets me 27, right? Times 3, I don't know what 27 times 3 is, 81. So again, for exponentials, you should notice your x's look like they're adding, but your y's look like they're multiplying. That's what exponentials look like when we look at them in a table. Again, we say that the output values are proportional when we're multiplying by the same thing. Again, logarithmic functions are the opposite when the x's are multiplying. So again, if it kind of switched, and again, exponentials and logarithms are inverses of each other. So again, if you see where the x's have the pattern where we're multiplying, times 3, times 3, times 3. The y's we're adding. It's a linear pattern. We're adding. So that's when it's going to be linear. So that's how you kind of know the difference between linear and exponential functions when you're looking at both of those. Again, if it's always adding, those are going to be the other ones we talked about in Unit 1, either linear, quadratic, or cubic. Again, we talked about this a little bit yesterday, but they could talk about fog or they could talk about Goff. If they put this little open circle, again, we're taking G, plugging it into F. And this is kind of where we started. So this was kind of everything we did in the kind of right before Christmas. And then when we came back in January, we started talking about fog and Goff. We started finding inverses. Again, using this little -1 means it's an inverse. Again, inverses are a fancy way of just kind of saying the x's and the y's kind of get switched. So our inputs and outputs kind of switch. Again, all functions should be 1-to-1. So again, every one input should have one output. Sometimes some functions will switch and not be functions, so be careful of that. And again, all functions will always be reflections over the line y is equal to x. So that's something to kind of keep in mind too. So then it talks all about the log stuff. So different properties of logs. Again, we can multiply two logs together if we're adding them together. These are going to come up during FRQ4. So they're going to give you stuff with logs for sure during FRQ4, and you will have to use these for sure during FRQ4. So again, you should know product rules. If we can add logs together, we can multiply them. If we're subtracting logs together, we can divide them. They're kind of opposites. Again, if you have a power in front of a log, you can move it to the front. And then you should know change of base formula. We could take log of the big number and divide by log of the base to evaluate any log using our calculator. So again, you should kind of know the base forms for both of these. So these are the base forms for exponentials and logs. At least kind of know what the graphs look like. And then you should know stuff about semi-log plots. If you remember, like the weird graphs where it gets like more and more further apart or more and more closer, actually. And again, they scale. Instead of adding on the y's, we're multiplying on the y's. they'll make kind of log graphs look like linear graphs when we kind of graph them on a semi-log plot. So that was kind of like the last lesson we did in Unit 2, if you remember going back and looking at, I think it was 215. So that was most of the stuff we did and talked about during Unit 2, kind of in a nutshell. So if you go back and kind of look in this middle part, it gives you a lot of other more in-depth note stuff. So again, more in-depth stuff about the formulas for arithmetic and geometric formulas, the first two things we talked about. Again, different characteristics of the graphs for exponential growth. Again, the exponent properties again. How to switch forms. So again, you should be able to switch between exponential and log form. Again, log properties, characteristics of a log graph. And then inverse functions they talk about again. And then again, semi-plots. All the parent functions we talked about in Unit 2. Kind of exponential functions and log graphs. So again, they're never going to, I don't think, ever going to make you really graph one of these by hand. So they're not going to be like, draw a graph of a log graph. That will never be a question. But they might give you a log graph and ask a question about it in the multiple choice section. So you should know what a log graph kind of looks like at least. So it's everything from Unit 2. This last page kind of has all of the different parent graphs from kind of Units 1 and 2 together on one page. Those are all the parent functions you should know. So other than the trig stuff, and then we'll get to the trig stuff tomorrow. So because this is all Unit 3 stuff. If you want to follow along with an FRQ2, I'm going to go through at least one. So you have your FRQ2 packet. FRQ2, some things about FRQ2 you should know. It is going to always be a word problem. So for some people, that's a good or a bad thing. Let me pull this up so you guys can see this too. So some things about FRQ2 to kind of keep in mind before we do an example. Again, it will always require the use of a graphing calculator. It will normally focus again on Units 1 and 2. It will normally not talk at all about Unit 3 or any trig stuff. Things it could talk about, it could talk about polynomials, again, linear, quadratic, could possibly do cubic. Could be a piecewise function if it splits a function in half and gives you two different pieces. Could be an exponential function, it could be a log function. So normally, these will normally be something with the regressions on your calculator. If you remember putting everything into the list, into the tables, normally they'll kind of have you put stuff into a table and use a regression to kind of find an equation. They're normally going to give you at least like 2 points. Sometimes they give you 3 or 4, kind of depending on the question. But that'll always be kind of part A, where they'll give you a couple points. They'll have you write equations using the points that they give you, and then they want you to solve using your calculator and using the regression stuff. Part B is always going to talk about the average rate of change, and I'll talk about the two formulas you'll pretty much kind of always use for part B. If you know those two formulas, you will probably get 2 points on part B for number 2. If you don't know those two formulas, you probably will not get the 2 points for part B for number 2. And then they'll normally ask a question about the average rate of change and how it compares to part A. For part B, that'll be kind of the last part. And then for part C, they will ask something about normally the domain and range, about the function and the graph that they gave you from part A. So again, stuff to remember in your calculator. You should know how to store stuff using Y1. You should know how to use all the equations and how to graph stuff in your calculator. You should know how to run the regressions in your calculator, and all of them. It's not going to tell you which regression you have to do, so you kind of have to know the difference between all of them. And again, your calculator will mostly be helpful for part A. It won't be too helpful for part B. It might help a little bit for the kind of the end part if you want to graph it. But other than that, let's look at some examples, or at least an example. So if you have your FRQ2 packet, look at those. Again, if you have a calculator, you'll most likely need a calculator for FRQ2. So here for FRQ2, for this first one, they do give us a table, which is nice. It says the table gives the number of cars in a parking lot of a local store. When the store opens at 8 a.m. or when time is 0, there are 4 cars. So they tell us 0, 4 is one of the points. Then they tell us when t is 5, there are 21 cars. And then they tell us 3 hours after that, when time is 8, there are 14. And so they give us this table of 3 different values. It says the number of cars in the parking lot can be modeled by a quadratic function. So notice it says by a quadratic function. L given by L of t is equal to a t squared plus bt plus c, where L of t is the number of cars in the parking lot t hours after the store opens. Use the given data to write 3 equations that can be used to find the values of a, b, c for the expressions of L and t. So again, I want to take these numbers, plug them in for t. You're going to get 3 different equations. So the first equation I'm going to get L of 0. L of 0 gets me a times 0 squared plus b times 0 plus c. So that's my first equation. That would equal 4. Then I want to plug in the rest. So if I plug in a 5, I would get a times 5 squared plus b times 5 plus c is equal to 21. They probably do actually want you to multiply this. So I get 25a plus 5b plus c would equal to 21. For my last equation, I want to plug in the 8. So I would get 8 squared, a times 8 squared plus b times 8 plus c, that would equal to 14. So again, they probably want you to square this. So I would get 64a plus 8b plus c is equal to 14. If you're able to find those 3 equations, you will get 1 point. You have to put all 3. If you only put one of them, they will not give you partial points. So you have to put all 3 equations to get 1 point. So if they say to use the data to write 3 equations, there has to be 3 equations. So make sure you do that. For part B, that's the part where we mainly are going to use or for part 2, sorry, we want to use our calculator. It says find the values for A, B, and C as decimal approximations. And notice it says you don't have to show your work. So I would go to your calculator, go to Stat, you want to go to Edit. I want to type in my little table. So in my list 1, I want to type in my 3 points from my X. I want to do 0, 5, and 8. In list 2, I'm going to list 4, 21, 14. After I'm done with that, hi. We're going through this right now. Once I do that, again, I'm going to go to Stat, go to Calculate. They said this was a quadratic function, so I want to go to quadratic regression. Be careful, this is a cortex. Don't get them mixed up. If I want to do a quadratic, again, it should look like this. So my X list is list 1. Okay. My Y list is list 2. And again, normally it's a good idea to store your equation in Y1. And to get to Y1, you go to alpha trace. Put Y1 there. It's a good habit. If you hit calculate, it will give you your answers for A, B, and C. It will tell you A is equal to, and again, they want 3 decimal places. A would be equal to negative 0.7167. B, I know. B would equal 6.9833. 67. I think you guys are kind of over it at this point now. And my C is equal to 4. So if you're able to find A, B, and C, you do have to find all 3 and get the right decimals for all 3. You will get a point. Again, that's pretty easy if you know how to use your calculator. So that's going to be part A. Part A will always be kind of the same. We'll ask you to write the equation using the points they gave you in the word problem. And part 2 will always be using your calculator to kind of find the values of A, B, and C using a regression. B will pretty much always start the same way. It will say, use the given data to find the average rate of change of the number of cars in the parking lot per hour between T is 5 and T is 8 hours. express your answer as a decimal approximation, and it does say show the computations that lead to your work. So if you don't show your work, even if you get the answer right, they will not give you the point. I've been told it's very true. So be careful. If it says show the computations that lead to your work, they want to see the computations that lead to your work. So average rate of change, you want to do y2 minus y1 over x2 minus x1. This is a formula you should probably know. I think I told you that the first day of class when I told you that would be for sure on the AP test. So again, since they want it at 5 and 8, I'm going to call 5 x1. I'm going to call 8 x2. I'm going to call 21 y1. I'm going to call 14 y2. I'm going to do y2 minus y1 all over x2 minus x1. 4 minus 21 gets me negative 7 over 4. Oh, it's a minus 5 and it's 3. Sorry. Negative 7 over 3. For 2, it says use the average rate of change from part 1. So you had to kind of get this part right or else you're not going to get part 2 right. To estimate the number of cars in the lot when time is equal to 7. Show the computations again that lead to your answer. So again, if you don't show them how you got your answer, they're probably not going to give you the point. So again, if you remember, I can use this formula, y minus y1 and m times x minus x1. So I'm going to plug in y1. Again, y1 was 21. M is the slope that I got from part 1. So I'm going to use negative 7 over 3. I want to find when t is equal to 7, so I'm going to plug a 7 in for x, since that's what they wanted. And then again, x1 is 5. So again, I got y1 and x1 from the table up here. I'm looking up here at 5 and 21. That was my x1 and y1 that I used. Again, the slope I got from part A, or from part 1. And now you have to find y. And you can use your calculator. So I would do something like this. In your calculator, you can type in negative 7 over 3, parenthesis, 7 minus 5. Gets me negative 4.667. And then I want to add by 21 to find y. I get y is equal to 16.333. So I would expect I would have about 16 cars in the parking lot. Or 16.33 cars. If you're able to show your work and get the negative 7 over 3 from part 1, you'd get a point. If you're able to find the 16.3 cars for part 2, that would get you a point. You also have to show your work. So you have to get it right and you have to show your work for both of those parts to get the full point. For 2, it's going to say the average rate of change found in part 1 can be used to estimate the number of cars in the parking lot at the time when t is greater than 0. Will these estimates found using the average rate of change be less than or greater than the number of cars predicted by the model L at time is greater than 8? Explain your reasoning. And so I would do this. This is what I would do. So here in my calculator, I have, if you stored it, I have y1 there. One thing you can do is you can go up to this plot and turn it on. Again, to turn it on, you can kind of, I think we've done this before, but I don't know if you remember. If you want to get to the plot stuff, you can hit second y equals. You can turn to this. You want to make sure the plot's on. Again, you probably want it to be a dot plot. Make sure the x's are in list 1, y's are in list 2. If you have all of that, you can hit zoom, and you can go to zoom stat. It'll give you a pretty good graph of kind of your quadratic equation going through those 3 points. You can tell when time is greater than 8, it's going down, it's concave down. my rate's going down. I could also type in the equation I got from part 2. So again, if I kind of type this in to see what's happening with my other equation, I can type in what I got from part B. The slope was -7/3 times x minus 5 was my x1 plus 21. Oops, not a 1. If you can graph that, you can kind of see this is finding the average rate of change between those 2 points, right? That's what we just did for part B. If we kind of zoom out a little bit, you can zoom out, go to zoom. If you don't know how to find it, go to zoom and then zoom out, and you can just hit enter. It'll zoom out a little bit. We can tell our graph when it's bigger than 8. The blue one is the one from part A. The red one's the part from part B. I can tell the one from part B is going to be greater. So it depends on how you want to say that. So again, for 3, you're going to say the average rate of change will be less than model L, or will be greater than, sorry. Again, model L is the blue one, the quadratic. The average rate of change we just found is the line, right? So the average rate of change is bigger after 8. You could tell it's higher than the blue one. So if you're able to say that, you would get a point. So and then part C says the model L is an appropriate model to make predictions about the number of cars in the parking lot when the parking lot has at least 0 cars. So again, we don't want to have negative cars, right? So based off this information, what's the largest number of t which the model is appropriate? Give a reason for your answer. So again, if I go back and look at my graph, looking at this blue graph, I can only use it when it's bigger than 0. So the domain's going to kind of stop over here at 0 and over here when it goes negative. So I want to find when it turns negative. To find that, you can go to second trace. Again, this will give you a bunch of stuff. I want to find the 0. When is it crossing at 0? Again, you can kind of use these arrows. It's going to say left bound. So I want to go left of where it's crossing, hit enter. It's going to say right bound. I want to move the arrows so it's to the right of where it crosses. I want to hit enter, and then it's going to say guess. So again, I want to put this around where it's actually crossing. So it's going to hit 0 at about 10.2867. So again, L of t equals 0 when t is equal to about 10.2868. The 7 will actually go up to an 8 because of the 6. So because of this, I would say I would only use model L before 10 seconds. Or 10 hours. Was this hours? Yeah. 10 hours. Since it turns negative after that. Something like that. So again, we wouldn't really use negative time, so we don't really have to talk about going backwards in time, right? When these would be negative over here. But again, it's going to be negative kind of past 10 over here. So I can only use it kind of between 0 and 10 hours. That's when I would want to use the model from part A. So, because we don't want to use it when it's less than 0. If you're able to tell me that, you would get 1 point for C. So again, that gives you a total of 6 points. So 2 from part A, 3 from part B, and then this last point from part C. Normally, the 2 hardest points to get are normally going to be the last part of B and point C because you have to explain. So more about explaining and you actually understanding what they're talking about than calculating anything. So that's pretty much FRQ 2. Pretty much what most of them are going to look like. So You can kind of tell if you look through some of these, they pretty much all look, for the most part, fairly similar. So again, you can use these to study for your test next week. All the answer keys for all of these are on Google Classroom if you look under today. So that's FRQ2. Any questions about FRQ2 for right now? You guys have the rest of the time to kind of go over the other ones if you want to work on those. If you want to work on the multiple choice practice for Unit 2, you can work on that too.